So what are the steps involved in factoring this quadratic? We look at it, we see that there's no greatest common factor that's useful for us to take out, and therefore we can't use the simple sum and product method. Instead, we have to use the souped up sum and product method that we talked about today. In my souped up method, I need a product to shoot for, and I need a sum to shoot for. What's the product that I need to shoot for in this example? What should my two numbers multiply to give me?
-30.
-30. And where'd you get that?
We'll multiply the 5 and -6.
Yes. So that's the AC in the AC method. Multiply the first coefficient, the coefficient of y squared, times the last coefficient, which is the constant. Multiply them together, we get -30. That's the product that we're looking for. And the sum has to be, what do they need to add up to? 13. Okay. So we need a pair of numbers which multiply together to give me -30 and which add together to give me 13. So give it a few moments thought and come up with that pair of numbers. What do you get? If one of them is 3, the other one would have to be -10. 3 plus -10 is -7. So that doesn't quite work. We're getting close. So what'd you say? 9 and 4? Those multiply to 36, not 30. -2 and 15. I think that one works, because now the product is -30. The sum is 15 minus 2, which is 13. So that's the pair that we want, -2 and 15. Which, you know, there is still some guess and check involved in the sum and product method, right? You may have to try a few combinations before you hit upon the one that works. It's better that the guess and check be limited to that step in the process than it is a more open-ended guess and check method, which is the other way to factor these, which we don't do. So now that we know that, now I go straight over to my table. I have my 5y squared in the upper left. I have my -6 in the lower right as my constant. And now we've just decided that -2 and 15 are going to be the ways that we split apart our middle term. So actually it gives me two choices. I could put -2y here and then 15y here. Or I could put the 15y in the upper right and the -2y in the lower right. Which way do you do it? It doesn't matter. That's the good news. Whichever way you do it, you're going to end up with the same factorization at the end of the day. And that actually should be really good news. So there, you can't screw that step up. So from here, we proceed in the same way as before. Looking at the first row, I want to know what's the greatest common factor of the terms in that first row. Between 5y squared and -2y. 1 for the coefficients, and yeah, we'll include a y to the first power because that's the smallest power of y that we see in these two terms. So if y belongs here on the outside of my table, then what belongs right there above the 5y squared? What do I have to multiply y by to get 5y squared? 5y. And how about this spot? What do I multiply it by to get -2y? -2. Okay, so now we're proposing that one of our factors is 5y minus 2. To finish the other one, we just need to fill in this space in the lower left. What do I need to multiply 5y by in order to get 15y? 3. And our last consistency check is it true that plus 3 times -2 gives me -6? Yes, so we did it. What are our two factors? Y plus 3 times 5y minus 2. All we have to do is read the first column outside the table and the first row outside the table. Those are our two factors that we get when we factor with this method.